in listen-only mode.
Well, good morning, and welcome to Whitmix's webinar, 3Shape Implant Studio 102, Edentulous Surgical Guides, with Evan Kemper. My name is Bernie Jaroslow. I'm the marketing manager for Whitmix, and I'll be facilitating today's webinar. So I'd like to begin with a few housekeeping items. First, in the upper right-hand corner of your screen, you should see a questions box. Please feel free to type in any questions you might have throughout the presentation, and at the end, Evan will answer those. Next, if you are a CDT, this webinar is approved for 1 hour of CE credit toward your recertification. You'll receive an email within 1 to 2 days. I will tell you exactly how to obtain the credit. Also, the webinar is being recorded, so within about 48 hours, it'll be up on the Whitmix website in our webinar section. So this morning I have the pleasure of introducing Evan Kemper. For those that don't know him, Evan's a senior technical specialist at Whitmix. As a certified 3Shape, Roland, and a SIGA trainer, he develops and conducts CAD/CAM equipment and software training, develops CAD/CAM products for Whitmix, and provides technical support and assistance to our digital customers. Evan's a graduate of Lexington, Kentucky's Bluegrass Community and Technical College in Dental Laboratory Technology and received his bachelor's degree in computer science from Transylvania University in Lexington, Kentucky. Today, he'll be speaking about one of dental technology's newest and most profitable dental lab product offerings, surgical guides. Laboratories marketing these to their accounts provide a needed and vital service. The technique for designing and printing them is very specific, and 3Shape has come up with Implant Studio, an excellent software package that helps technicians make them with very intuitive tools. This webinar today demonstrates in a step-by-step manner how to design and fabricate surgical guides for the edentulous patient. So that's all I've got. Evan, if you're ready, let's talk about making surgical guides.
All right, sounds good to me. So today we're just going to be covering the Edentulous guide option. There is an Implant Studio 101 webinar from last year that covers tooth-borne guides. So if you want to see some of the more, I guess, dialed down, what button to push, how to manipulate certain things, that's all covered in the 101. Today, it's going to be more of a high-level overview of the Edentulous, just because there is more to this workflow, so it takes a little bit more time. So we'll start out with how to create the order. So we can just create a new order form by clicking New. And then for the Edentulous ones, we really just need to select one tooth on the arch, go to Implant Planning, and then instead of selecting tooth supported, we need to go to Edentulous and make sure that we have Implant Planning checked and surgical guide checked. You can get versions of the software where you only do Implant Planning, and then in that case you wouldn't have the surgical guide checked. So this is, if I just have Implant Planning checked, I'm just doing the planning, and then it can be sent to somebody else with Implant Studio to make the surgical guide. But today we're going to do both. And you can see it just highlights the whole arch. So you're not picking the specific teeth where these implants are going to go in the order form like you do when you do the tooth-borne, just because this workflow allows for you to place as many implants as you want during the design. So from here, we're going to just click Next. The other difference on the Edentulous workflow is that you don't have any surface scans. The two scans that you need are, one, of course, is going to be the CT scan of the patient's head, and then you also do a CT scan of an existing denture. That denture needs to have radiopaque markers placed in it, and the CT scan of the patient is going to have the denture in the mouth with the radiopaque markers in it. And then the scan of the denture outside of the patient's mouth will have been painted or sprayed with a radiopaque substance so that the entire denture is picked up. Essentially what that's allowing us to do is capture the tissue surface from the intaglio side of the denture. So we'll go ahead and just click on Import Lower Denture. CT scan, and we're going to get our denture scan. And after it loads it, it's just going to let us preview the slices in the DICOM file. And you can just preview it by sliding these sliders. And so now we have a 3D preview of the denture scan. And the reason, again, that we can see this whole scan in a CBCT scan is because it's been painted with a radiopaque material. And you can see on the lingual side the little radiopaque markers that have been placed. And when we import our patient CT scan, you'll see how the radiopaque markers show up. Again, we can preview these slides, and if you look at this one, you can see right here these two little white spots. Those are those radiopaque markers. Now, when the denture is in the patient's mouth, all the denture should just only have the radiopaque markers, no radiopaque spray or paint on. And that way, all it picks up in the head scan are those markers. And that's how we're going to be able to do the alignment. So now with the patient's head CT scan, you can kind of see that a little better. There are the radiopaque markers just kind of floating in space. And because the denture wasn't painted with a radiopaque substance first, it's not going to also be included in this CT scan where we're going to be doing our implant placement. So after we have them imported, we're going to go on to go next, and we're going to trim up these CT scans, mainly to reduce the amount of memory that is used during this design. One important thing to note about doing the Edentulous workflow, if you look under this graphics information, you need to have a graphics card that has at least 4 gigabytes of dedicated graphics memory. If you don't have that, it's just not going to run very smoothly, or you may not even be able to do the workflow. So if you're thinking about getting Implant Studio, just keep that in mind. You may need to buy a new computer or upgrade an existing one because of this limitation. So what we're doing here in each one of these windows, we're just trimming down the size of the CT and getting rid of information that we don't need. And to do that, you can drag the slider to preview the different slices, and then these little blue boxes, we just drag the control points around, and anything outside the blue box is going to get cropped. So just like cropping a picture on your phone. And you just want to go through the slices with this slider to make sure you're not getting rid of anything that you actually need. So right now we're working on the patient CT scan, so I can get rid of all the maxillary information because I don't need it. So that looks pretty good. So I'll just click next, and now we crop the lower denture scan. Okay, now we go to the next phase, which is doing the panoramic curve. So we're just going to adjust this plane, and just like in the tooth-borne workflow, I'm going to bring this down so it's intersecting the jaw. And then in the axial view, we're just going to adjust these yellow points by left-clicking and dragging, and just make sure that they kind of fall in the center of that arch. and you'll see it adjusting the panoramic curve just to the left of me. All right, let's go next. And now you can see the software has already automatically tried to identify some of these radiopaque markers to do the alignment. And so essentially any of the ones that don't have the blue and orange, or in this view, the orange and blue dots overlapping each other, then we need to select these markers. And you can see how it adds that blue circle on the right side view. And then any of them that are not correct, we need to unselect. And essentially that's telling it exactly how to do the alignment. It's found the radiopaque markers on the denture and on the CT scan. So then we can just go to confirmation. And if we want to go through any of our views, we can do that just to see how the denture relates to the bone. So essentially what we want to see is a gap here, because we know there's soft tissue in between. If you saw the bone intersecting the denture base, then your alignment's probably off and you need to go back and adjust it. So then we'll just confirm the alignment by clicking in that box. Click next. In the next phase, we are selecting essentially just the tissue side, the intaglio side of the denture. Anything we select will be considered the tissue surface for making the guide. So one note on this also is 3Shape Implant Studio does not allow you to do bone reduction guides. And I believe the reason for that is there's a patent on that technology right now. So these are edentulous ones, but if bone reduction needs to be done, that can't be done with this software. So after we select the tissue, we'll just click next. Now we have to, since we're on the mandibular, we have to map the nerve. If we were on the maxilla, you don't have to map anything there. So what I'm going to do is move the crosshair on the panoramic view and try and find the nerve exit. So there we found it in the orthogonal view. You can see it right here. And I'm going to maximize this orthogonal view. 2 clicks to map the exit of the nerve. And then if we hold if we hold control and scroll the mouse wheel, we will be scrolling through that view and continually clicking to map the nerve canal. And you can see if you look at the other views that they're mapping in that view as well. Now sometimes you can scroll through the tangential view and find that nerve canal and quickly map it. And just to confirm, I'm going to look at it in the 3D view, just to make sure it looks like it's in the right spot. Looks good. So now I'm going to go next. I'm going to map the left side. Again, we're going to confirm it in the 3D view. Click next. So now we're in the implant planning phase. So to start, you're just going to select a tooth. You can see I can select any tooth on this arch for placing an implant. So we're going to select a tooth, and then we're going to pick an implant library. So there's quite a few that 3Shape supports. I'm going to use Strawman today. And then once I click Strawman, I have any available implant that Strawman has provided in a library for Implant Studio. The other thing that is needed for the Edentulous workflow are anchor pins. So you can see I've got anchor pins over here. Essentially, that's what keeps the guide in place since we don't have teeth to support it. So if I select an implant, then I also have the option of which platform, the diameter, and the length in this table. So I'll just pick the 4.8 by 12 millimeter long. I just double click that. It's going to bring me back to this screen, and I'm going to drag this crosshair on the panoramic view until I get to a place where I think I want to place that implant. Once I've done that, I'm going to come over to either the orthogonal or tangential view, and you can see the outline of my implant. I'm going to do a single click to place the pivot, and then a final click to orient the implant. Now, once you've placed the implant, you've got a couple different options you can do on the implant align 90 degree or implant align 0 degree views. If you just left click and hold, you can drag the implant around. These red balls will allow you to rotate the implant. Now in this slice, we can see our denture, and then the pink is our tissue. And so, and this gold that you see is the sleeve. If the sleeve is intersecting tissue, which we'll be able to see a little bit better in the 3D view, it's going to be gold like this, and essentially you can't go forward with the guide if the sleeve's touching the tissue. You've got to either move the sleeve up or change to a different sleeve library. If I had picked, say, the longest offering, the 14 millimeter, you can see that this safety zone, this outer line, which is a safety zone around the implant, is intersecting the nerve. And what that's saying is if you want to use this recommended safety zone, you need a shorter implant because you're too close to the nerve. So with this green slider, I can slide it back to that 12 millimeter, and it turns green. You know, we're good to go with that safety zone. Now, things to consider that the software doesn't automatically do is, you know, the amount of bone you have to either side of this implant. You know, the safety zone is not going to analyze the bone surface, only the nerve or another implant that was placed near it. If you need to use a custom safety zone, you can do that by clicking the Set Custom Safety Zone button over here on the left of the screen. You just have to check the box to enable it. You can see this is turned yellow now, which will indicate in the surgical report that a custom safety zone is used. And then this allows you to adjust the distance around the implant for the safety zone. And you can see it change on the screen. I'm not going to do that for this. So you want to do your alignment in the implant align 90 degree view, then check it and maybe make some adjustments in the 0 degree. And then of course you always want to check the 3D alignment. This top slider over on the right will allow me to hide the denture and just have the tissue scan showing, or tissue side of the denture scan. And you can see here that the sleeve is hitting tissue, so I need to move that sleeve up. And as soon as I move it to where it doesn't intersect tissue, it turns gray. That means we're okay to move forward with that implant. So we'll just go back to our docked view, and then we'll move on to the next implant. Same process, we just click the tooth that we want, pick the implant we're going to use, move our crosshair, single click to place the pivot point of the implant, and second click to finalize the placement. And then again, we're back to our implant align views to adjust this placement. So you can go shorter or longer with implants right from the implant align views just by dragging the screen ball. You don't have to go back to the implant selection window. And we're going to change our sleeve height. And go to the next implant. These little pop-ups that keep coming up, when you first get Implant Studio, it's going to have these little pop-up hints that kind of tell you what you're supposed to be doing. If you don't want those to show, just make sure you check the don't show this again box every time they pop up and you close them. So we're going to place a third implant. And the fourth one. So I need a shorter implant. I'm just going to drag that green slider. And adjust our sleeve height. Now, let's say this is going to be an all-on-4 case. We've got all of our implants, but we need to place the anchor pins. So for anchor pins, you're just going to select a tooth in the general region of where you want that anchor pin. And then we're going to find an anchor pin in one of the libraries that we want to use. So I'm going to stay with Straumann. And you place these the same way you'd place an implant. So we need to move our crosshair and go to one of either tangential or orthogonal view. And again, single click to place the first pivot point, and then second click to place the pin. And then we just need to make any adjustment to the position. It needs to intersect the tissue, the pin does, or it's not going to be part of the guide. In the guide phase, it actually uses this tissue form to create the intaglio side of the guide. So if this pin's not intersecting this pink line, then it's not actually going to be anchoring anything. So just make any adjustments you want. Think about patient comfort and how the cheek's going to have to be spread with the position of these. You don't want them all the way in the posterior or facing the posterior. If you need to angle them, you want to angle them towards the anterior. So you can see the change in that position there. So once I place that one, I'm going to place at least 2 more. So I'll just click the tooth that I want to use, select my anchor pin, move the crosshair, and place the pin. Just going to verify the position of it and move on to the next pin. Again, removing that crosshair, go to the orthogonal view, and place the pin. I'm going to rotate it just a little bit more towards the anterior and check the placement. Looks good. So now we have 4 implants placed and 3 retention pins. The only other thing that you might consider here beyond, if more implants and that sort of thing is if you want to keep the implants parallel, you can actually group them together. And to do that, you just select the group implants together, and then you select the tooth that you want to be the lead and what it's going to align everything to once we click the group button. So let's say we wanted 19 to be the lead implant, and then we select anything else we want grouped with it. So let's say 22, 27, and 30. Once I hit this button, all of these secondary implants are going to align to 19. So you can see how they all just shifted. Now, this isn't always the best thing to do, and especially with newer technology and custom abutments where we have the multi-link or 2-stage abutments where you can place non-parallel implants and not have an issue on the restorative side. So really, I'm going to undo that. I don't need those lined up in parallel. So now, after I'm done with the placement, I'm going to go on and go next. And now we are into the guide design. It's already pre-generated a basic one-piece guide, but that may not be or always be something that's going to work for each case. So the big thing on the Edentulous guides is the patient has to be able to bite down on the guide to seat it while the anchor pins are drilled. So if one of these sleeves would interfere with the occlusion, let's say if it was higher up and this, so you've got those different options here. By default, it's going to do just a regular one-piece surgical guide, and you just have to make sure that none of the yellow surfaces interfere with the occlusion, or that there's enough remaining occlusion for you to be able, the patient to be able to bite on it and seat the denture. If in this case we could get away probably with the one-piece guide, it looks like there's enough posterior occlusion that we could seat this. But let's say we don't want a one-piece guide. But the other option we have is a 2-piece surgical guide. If we click that button, it's going to assemble a 2-piece guide. So we'll wait for it to do that. So the way the two-piece guide works is that it will create a guide with all of the sleeves and anchor pins, and then a piece that will seat over top of that with the denture occlusion. So you put the two pieces together, put it in the patient's mouth, patient bites down, anchor pins are drilled and seated, and then you take the denture tooth part off and you have your regular surgical guide sleeve access. The other option we have is to enable dual surgical guides. And the way that works, what you can see in the top window is essentially the denture with only the sleeve holes in it. And then in the bottom, we have just a basic guide with the sleeves and anchor pin holes. So the way this works, the one on the top of the screen is placed first. Patient bites down, all the occlusion for the dentures there. The anchor pin holes are drilled. Then that comes out. We're not keeping that in the mouth. Then the secondary guide goes in. The anchor pin holes are already drilled, and then you insert the pins through the anchor pin holes on this bottom guide, and then do the surgery through the sleeves. So you've got three different options, and it's going to vary case to case. It's going to depend on essentially what the case calls for. So here, back on this two-piece guide, you can kind of see that a little better when I pull that up, what the two pieces are going to look like. Now, with the two-piece guide, you really need to make sure you have a printer or mill that's capable of printing accurately enough that this fits together well. If it doesn't fit together well, then it's not going to be accurate for the surgery. So probably my preference on it if you can get away with the single guide, that's probably the best option. But if I had to pick between the two-piece guide or two individual guides, I'd probably go with the two individual ones. So once we picked what kind of guide we're going to do, we also have the ability to change the sleeves at this point. If we want to change sleeves, we can click the sleeve button. And depending on the manufacturer, in this case, Straumann does provide a sleeve library, but depending on the manufacturer you're using, you may have more or less options on sleeves. So Straumann offers a fully guided option, and then they also offer just a pilot, which you just drill a pilot hole, and then it's from there you take the guide out and do the surgery without a guide. We'll stay with the fully guided on here, but if you go back, there's a whole lot of other sleeve libraries here. A lot of them are third party. If there isn't a sleeve already in your manufacturer's library, then you probably have to pick one of these third party sleeves. But you would need to make sure that the doctor, the surgeon, has the appropriate drills and everything to go with that third party. So Straumann also has a T sleeve here. So just a little bit different sleeve, and it's kind of up to you to use what the surgeon has. So there's definitely needs to be some collaboration on that end of it. But beyond that, it's as long as the library is in 3Shape, then you can make it. And on that note, if there's a system that's not in 3Shape, it's not something where, like if you're familiar with Dental System, where you can call the manufacturer, they give you a DME and you put it in the control panel. Anything in Implant Studio has to be added by 3Shape in a software update. So if you don't see a library or an implant system that you need, then you would want to contact that manufacturer and suggest that they work with 3Shape to get their implants in the system. And it may be something they're already working on or didn't cross their radar, but now it's there. Beyond the sleeve libraries, there's also a list of production systems. So you can see here, like I've got a 3D Systems printer, ProJet 3510 MP, and then 3D Systems PhysiJet Stone Class. All of these systems have to be added by 3Shape. Again, it's not something where you can get a material file from Whipmix and import it. Now, that's not to say that if you don't have one of these printers that's in here, you can't make a guide. But essentially what each one of these does for the system is it sets a manufacturer preset for the offset from the sleeve, the offset from the tissue, and minimum thicknesses. Now, depending on what the manufacturer recommends for that printer and that material, there will be limitations on how much you can adjust these values. So if your printer is not in there, then you can just find one of these options that allows you to adjust the necessary fit values so that you get the fit you want. And there are 3 other values that you don't see here because they're not really important to Edentulous guides. Really the only thing that's important to the fit of an Edentulous guide is the sleeve offset. But for tooth-borne guides, which you can see if you go and watch the previous webinar, you have the offset from the teeth, which is going to determine how it fits and seats. There's also undercut retention value that you can adjust, and a thickness value. So, and the reason you're not seeing the thickness value on this is because it's using that denture CT as the guide, so it's going to be plenty thick. Yeah, so if we switch it over to the 2-piece one, you can see a little bit more of those values that I was talking about. Usually, no manufacturer is going to specify a retention amount. Most of the fit of these is determined by the offset between the pieces or the offset between the tissue, just a friction retention. And then, of course, the thickness of the guide needs to be thick enough that it's not going to distort during seating or surgery. Most manufacturers are going to recommend probably 2 millimeters or more for any of these printed surgical guides or even milled ones. And then the offset from the sleeve, again, that's the offset from this metal sleeve to the guide. It needs to be loose enough that you can insert the sleeve, but not so loose that you got a lot of rotation. So after we've made sure we are using all the sleeves we want, we selected the right printer, we can move on to modifying the fixation piece. And essentially, anything you do here as far as painting with a green surface, that's going to remove that from the seating surface, the part that goes on and around the other guide. Now, the reason you might do this, when it first makes it, now let me undo. You can get some really sharp knife edge kind of areas and things that can actually hinder the ability for this to snap on over it. So if you eliminate some of this border down here, that can help with the fit of this top piece. But I took a little bit too much off of it. And what I'm doing right now is I'm just holding control, and that reverses what the tool does. And then anytime you want to see what it's going to do, just hit preview. And until it's actually generated the changes, it won't allow you to actually go to the next step. So from there, I can go next. And if I want to, I can add a ID tag. One note, if you're going to add an ID tag to this two-piece one, make sure that you invert the text. Otherwise, you're going to have fit issues. And it looks like they've changed it to where it's going to automatically do that now. But I can just type whatever I want in the ID tag field. And the way that the placement of this text works in Implant Studio is it's going to be oriented essentially starting where your mouse is and then horizontally out on the screen from there. So the positioning on the guide, you actually move the guide to change the positioning of the text. You don't put the text on and then move it. You have to change how this guide's oriented. So you just place the text. You can change the size by changing either the small, medium, large. You can't change the preset values for these. Then we're just going to click preview. So it's cut it in, and it's a negative engraved text, so it's not going to affect the fit. So I can go next and place an ID tag on the secondary portion. And I'm going to invert it just by clicking the invert ID tag. After you've finalized the guide, it's going to prepare the surgical report and the drilling protocol. There's 2 steps to this, and once you've actually checked the approved planning and approved surgical guide, it's going to restrict what you can go back and change. And this is preventing anything from being changed after it's been approved by the surgeon. So the first thing that you have to approve is the surgical report. So if I just click show surgical report and you just find whatever your default PDF viewer is, then it will pull up this surgical report. It's got a field to be signed, and it states, this is the for approval version of this. So the case hasn't been approved with the current planning. You get the 3D preview, each implant's information, including the tooth location, the size, everything needed for ordering the implant. So here's even the number that you would order from Straumann. So again, we've got each different implant. We also have the pins. Then each implant is going to show the placement, both in 2D and 3D. You'll get a bone density readout. And you can see the same thing. We'll get that for the pins. So essentially you print this off, take it or send it to the doctor, have them sign it. Once they've approved it and signed it, then you can approve the planning. Now you can see when I click there, I get a little pop-up. It says, after approving the implant planning, you will not be able to modify it. Do you want to continue? So if modifications needed to be made to the planning, you would of course not approve it. You would go back in the planning phase, make the changes that are necessary. Once I click yes and approve that planning, you can see it's changed the implant planning stage icon to have an eye on it. That means that it's been approved, and if I go back to that phase, all I can do is view the planning. I can't make any changes. If I needed to make changes, I'd have to make a whole new case. You could copy this one if you wanted to, but this case ID, the planning is now locked on. And if you look at the surgical report again, it's now changed to approved. So once you have the signed copy, you could print out this copy, and that just shows that, you know, I have the approved surgical report. I haven't made any changes. All the data is the same between the one that's signed and this one. So I haven't, you know, made a copy and then made changes to the guide that way. So now that the planning is approved, if I needed to, I could go back and change the sleeve or change the surgical guide. So like if I went back and let's say, okay, well, we don't actually need a 2-piece guide. Let's just go to a 1-piece. Then I can still go back and change the surgical guide, but I can't change the planning. And so once the surgical guide's approved, you don't have to print something out and take it. This is more of just, you know, if you want to talk with a surgeon about what kind of guide they want, and then they approve, oh yeah, we'll just do a 1-piece. There's nothing official to sign. It's just once it's approved, and you click this button and say yes, then it's going to lock that guide design down, and that will give you the drill protocol. So you have to approve the guide to get the drill protocol, because let's say, you know, even yeah, I'm using Straumann implants, but let's say I switch to a non-Straumann sleeve, which you could do in the surgical guides section, then that's going to change my drill protocol, because I got to have different drills. So if we look at the drill protocol now, this tells the surgeon exactly what they need as far as the implant number, the sleeve number for the guide. And actually that might be something you use when you order these sleeves and glue them in. It tells them sleeve height, sleeve position, and which exactly, you know, the steps they go through with each different drill. Now, depending on which sleeve library you use, this may be more or less detailed. I've found that Straumann is one of the highest detailed ones that I've come across. So as far as the, you know, drilling protocol instructions, you know, your mileage will vary depending on this, what information the sleeve manufacturers supplied. So once everything's approved, we go next, and it's going to generate the guide. And I didn't preset a output folder, so I just have to specify where I want it. We'll just put it on the desktop. And it's going to generate the cam output. And along with the cam output, it'll generate a 3Shape DCM of the arch that has the implant position information in it, which allows you to import it into Dental System to make immediate abutments or custom healing caps, anything that you would want to immediately load on these implants. So we just minimize, then we have our folder here. So we have the guide, or sorry, that's the lower tissue scan. We have the lower jaw scan with implant info. This is what you would import into Dental System. And here's our surgical guide. And you can see you would buy your sleeves. They're indexed, and you would insert and glue them there. You do have to use sleeves because drills would go right through any of the print or mill materials. They wouldn't be stable enough. You do need the metal sleeves. And then you have the drilling protocol PDF that you can print out and the surgical report in the approved stage. And so that kind of sums up the Edentulous workflow for Implant Studio, I guess.
All right, Evan, we have actually only one question, at least at the moment, and that is, do the sleeves have to be added into the guide manually after the guide is printed?
Yes, yeah, there is no current manufacturing technology that allows you to have the sleeves, inserted during the actual printing or milling. So yeah, you print it out or mill it. Most people are printing it because it's just faster and more cost effective. And then you would, buy your sleeves or have them on hand, and after it's printed and post process, you would insert and glue the guides or the sleeves. Sorry.
Okay. Another question just popped up. What type of composite do you use to glue the sleeves?
I mean, you can probably, it's like cyanoacrylate super glue is fine. I mean, as long as it's non-toxic. Or you could use probably any kind of, probably not like a composite cement, but I would say either super glue, or if you're printing it and you have the resin material that you're printing with, there's something, I didn't show it in this webinar, you can add glue channels. It's essentially a little hole that goes through the side of the guide into the retentive area of the sleeve. And if you want to see that, you can just reference the Implant Studio 101 webinar. But you could actually flow a little bit of the liquid resin through that hole, and then if you get a UV flashlight or even just use your curing box for your printer, put it back in there, and it will cure, assuming you're using a clear material, it will cure that liquid resin and lock it in using the same material that you printed the guide from.
Okay, we have a few more questions. Next, is there a recommended printer? And I can answer that one, but
yeah.
Go ahead.
I mean, we've had a lot of success with the Sega Max printer that, of course, we sell, and our VariGuide resin. Really, I mean, the printer side of it is going to depend on what you're willing to spend, I guess, on the, because you can go to the carbon printer. That's an excellent printer. They use our surgical guide material for that. There's a lot of low cost printers hitting the market, even lower than the price of the Formlabs. Those, I mean, for surgical guides, they would probably be okay. You probably have to do a little bit more adjusting on the fit settings, the offset from the sleeve, and of course they're not in that list of printers in the software, so you would have to play with those values and do a little trial and error. But I mean, probably any of those could do it, because the accuracy needed for the surgical guides, it'll be there for placement. It's just, you're going to have to play with the fit settings. But really where you're going to run into trouble with those is just they break. We've got a couple here and they don't hold up. So I would suggest investing in a decent quality printer, and also keep in mind, what else you might do with it. Models, a lot of these cheap printers, they don't have the accuracy to do sectioned models. You got to do solid ones and separate dies. So, but as far as being able to print them, you just need a DLP or an SLA printer and a material that's approved for guides. That's the other thing. The guide materials have to be approved, have FDA clearance for or up to an hour of intraoral use. So that's the other thing to keep in mind. Not all printers have a guide material necessarily.
Okay, good. Next question. Can you go through provisional abutment design and crown for immediate loading?
Can I cover it now? I'm not sure we have enough time to cover that, but maybe in a future webinar. But essentially that workflow, you just import that surface scan, and then it's like any dental system case for abutments off of a stone model scan.
Okay. Next is once you choose an implant and you adjust it to size, I guess, do you have to change implants, or does the software do that for you? Once you choose the implant and adjust the size, probably, do you have to change implants, or does the software do that?
No. So when I was dragging that green slider, change the length, it automatically does it. If you needed to change the diameter or the implant platform, you would have to go back into the let's pull this up. You'd have to go back into the implant library section, which is not showing here, but it's where I was selecting the implants. If you need to change the platform, you have to go back in there and select a different platform. Or if you're switching manufacturers, you have to go back and switch manufacturers. But once you select the implant, the software changes it for you. And then length you can control straight from these implant line views.
Okay. Next, can implants be planned and placed in the 3D view?
The initial placement can't be done in the 3D view. You have to place it in either the orthogonal or tangential view. But after that, you can keep this view up, but the control points for adjusting the placement are all going to be in these 2D views. The 3D view is mainly just to allow you to view the placement in 3D. But the one thing that you do have to do in the 3D view is your sleeve height. That you can only adjust the sleeve height in the 3D view.
Okay. Next one is what fees are being charged, and you might add to that what costs are involved to make. And I know it all varies, but what would you say is an average for the charge and the cost?
Well, it's right now in the industry, I think it's kind of a lot dependent on where you're located. I know there are some companies that they increase the charge per sleeve, so you can get into several hundreds of dollars for a guide. Like what we print here, we charge $100 to print the guide, and then you buy your own sleeves, and then you would upcharge from there to cover that cost. So a couple $100 to probably, I think some of them that charge per sleeve, you get into $1,000. But where you can really profit on them is instead of outsourcing, you get a printer, because the cost of the material for you to print is only a couple dollars, probably less than 10. And then all these sleeves are around $30 to $40 a sleeve. So you could charge $300 to $500 for a guide and only have $100 in it or something. So, but I would do a little market research wherever you're located to kind of see if there. I know a lot of people have had success where it's not really a thing that's been happening in their area, and they market it right, and they've kind of got the sole surgical guide business, and they can kind of charge whatever they want. But you would need to do some research in your area to see, what people are charging around you. So that would give you an idea of kind of what you could charge and keep you from going to market with something that's way more expensive than competitors near you.
Okay, we have 3 more, unless more come in. I know that some companies have set height for sleeves when designing the stent. Is there a way to override the heights? Like Nobel has 3 heights, 2, 4, or 6, I believe.
So when when I was moving these sleeves, you could see when they were yellow, there's a green ball that I drug them up with. That green ball that allows you to adjust the sleeve height is set to the manufacturer's different possible sleeve height. So for Nobel, there would be 3 notches that allows you to only adjust it to their different heights. Just like Straumann had theirs limited. There are some third-party ones that allow you to freely move them. But in the surgical report, it tells you what drill you would need to use, what the minimum length would be. But for most of the manufacturers that supply their own sleeves or make their own sleeves, it's going to have a preset value that corresponds with, you know, a combination needed for their fully guided drills.
Sorry. Okay, next question is, does the radiopaque paint remain on the denture? If it does it affect the look of the denture? And what is the drying time before placing in the mouth?
I mean, as far as drying time and before placing it, that would be something that the manufacturer would specify on the container. And most of them, I would say, come off. As far as what it's going to look like, usually I think what's used is the titanium dioxide, and so it's going to leave a white look on it. And then as far as the radiopaque markers, those can be pretty much any. I think BBs get used a lot, little ball bearings, there's metal, known size pieces. But yeah, as far as, you know, how to use or, you know, how long you have to wait before you would place it in the mouth, that would all be specified by the manufacturer of that radiopaque material.
All right, last question. What is the proper distance from sleeve to implant, and how does that affect the surgeon's technique in drilling and placing?
I mean, that's going to depend on really the implant manufacturer's recommendations, because they're all going to have a different theory or different research behind what they believe the appropriate distance between the sleeve is, and that's kind of why they restrict the sleeve to what their recommended setup or system use is. But generally, I mean, I would think the closest you can get is better, because it keeps the height of the guide down. It leaves you more room for the surgery. If you have something really tall, it's especially in the posterior, it's going to be hard to get the drill in. And in that case, there's also they have slotted sleeves where it'll actually leave an opening to the facial side where you can slide the drill bit through in case there's just not enough room to go in from the top. So generally, I would think as close as you can get, as long as you're not touching the tissue, because if the metal's touching the tissue, you're not going to be able to see the guide.
Okay, looks like we completed the questions. Evan, thank you very much. Great job as always. So I just want to repeat to everybody that this will be up on the WhipMix website in our webinar section within 24 to 48 hours. And in that same time period, those of you who are CDTs, you'll be contacted by us by email. You'll be able to fill out a very easy test, and we will take care of making sure that you have your recertification credit turned into the NBC right away. So thanks for joining us, and we certainly look forward to seeing you at another WhipMix webinar. We do hold them generally every other Tuesday, so watch for an email that will let you know what's coming up in the very near future. Thanks again. Bye.